Right, we'll carry on. I had a little problem with the camera there, so I'm hoping I haven't lost the thread of what I was talking about, but I think I got up to the point where we were talking about the rice pudding and the skin on the top, and it formed into a crust, which we call the crust of the earth, and then it began to split. This land mass, which was called Pangaea, began to split up into various pieces, which we now call the continents, and these continents move about on the surface of the earth very slowly. We don't even notice they're moving, but over millions of years, these continental drift, as they call it, where these continents moved around on the earth, and in different places, strange things. I mean, that the earth has moved around, and what was at the bottom of the earth has moved up to the top of the earth, and various other places like India has bumped into another continent, which form the Himalayan mountains, because when these continents bump together, they force the land mass up and they form mountains, the mountain building processes, and you get sort of earthquakes and volcanoes and all sorts of things like that, where the earth's crust subducts. In other words, it goes down underneath one layer of skin, goes down underneath another layer of skin, and it causes the earth to heat up that material and cooks it back up again, and then it bursts out of the top through volcanoes and various things. Now, that process is actually what you could call chemistry, but on a very big scale, because what you do in chemistry, very often you get different chemicals which have all come out of the ground. Everything comes out of the ground, as I've said, and you get those different chemicals and you mix them together and you cook them up in the very same way as the earth does, and you produce other things. So it's a sort of a chemical process that's going on in the earth, and it's still going on now. It'll go on forever and ever, for as long as the earth survives. And this constant churning of the earth, where one piece of earth goes down underneath the other, and then it'll split apart somewhere else, and waters is associated with it, and all these different minerals that we're talking about have actually been produced in this huge chemistry lab, which is the planet Earth. It's a huge chemistry lab where all these different materials are produced. Now, some of these materials that are produced are the rocks, and there's various kinds of rocks and minerals. Now, I suppose the definition of a rock is a rock that's had some chemistry to it, but it's very often been volcanically turned into some other kind of rock. So you find different rocks that are laid down from volcanoes, like volcanic ash, and things like that, which have spurted out of volcanoes. I'll show you one or two rocks that have come about as a result of volcanoes. And then there are other materials that form within those zones where the volcano came up, and it passes through other rocks and changes it slightly, and gases are produced, and these gases congeal and solidify and change the surrounding rock, and it produces minerals. Now, minerals are very useful. I mean, every day we're using minerals all the time. I mean, the very fact that I'm talking to you now is a result of minerals. Without the copper that's in the earth, which is formed, which I'll show you rocks which contain copper, without those metals, various metals and silicates, and the screen that you're watching this on is sort of as a result of quartz crystals and diodes and all sorts of technical things in science are made from the materials that were once found in the earth. Now, surprisingly enough, I've got a chart here which you may be familiar with. I don't know, I'm sure you are, but it's this one. Now, the light's not very good on that. I better just change it over, it's too bright. But that chart, and I'm sure you recognize it, it's what's known as a periodic table. Now, on there are a sort of a list of all the elements that make up everything we have on the earth. I mean, we're up to about 120 actual elements. Now, these elements are sort of pure state materials that are formed from different materials that the earth has created, and from those these are the ingredients, I suppose. The recipes are when you do the science and you mix together different chemicals off this periodic table to make things in chemistry. Now, it's interesting to note that when you look at this periodic table, while we're just looking at that, that nearly everything on here, I mean, some of the names won't be familiar to you, but some of them are, and things like copper, which we've mentioned, and silver, and gold, mercury, zinc. Now, these are all minerals that are, and elements, which are in their natural state. Now, one thing you won't find on here is steel. You'll find iron, because as I said, the earth has got an iron core, they say, and a lot of iron rocks, and again I'll show you some iron rocks, but you won't find steel. And the reason for that is that steel is actually a mixture of iron and other minerals. I can't just remember offhand what they are, but only the pure minerals, only the pure state materials are listed on this periodic table. Now, when you mix them together and form other things, then they're a sort of a mixture of things like aluminium. They're a mixture of different elements, and so you won't find those on the periodic table, although they exist within our world. Now, this is a result of mixing various things together and sort of making things, cooking up a recipe. You get a recipe just like making a cake. You'll put all different mixtures in, flour and water and eggs and fruit and goodness knows what, and you'll cook it in the oven and you'll produce a cake. Well, that's a bit like what some of the things are made of. They mix them all together, do a recipe, cook them up, and lo and behold, you end up with something that's very useful. And these are all the time sort of things that can be made by using natural resources, natural substances, which are on the periodic table, and then cooking them together and producing something else. Now, getting back to our rock situation, I mentioned that we got rocks, minerals and fossils. Now, there's a lot of rocks which aren't sort of pure rocks. They are rocks as a result of one lot of rock dissolving through erosion and going down through rivers and what have you, and into the sea, and the sea itself changes things. The animals that live in the sea eat those minerals, and they produce things like calcium, and their bodies are made of it, and it sinks to the bottom of the sea. And those are what they call sedimentary rocks. They're still rocks, and I've got some example of them which we'll show you just in a minute. And those rocks are produced in a different way to the volcanic rocks. These are produced by sediments which settle on the bottom of seas, and then by the action of the tectonic plates move around the earth and come up above the sea. The sea goes away, or it comes somewhere else, and you find that these rocks come out and they're on mountains. I mean, I live in Shropshire, England, and it's a fascinating area, which was just lucky for me, I suppose, that I was born here, and therefore I didn't realise it, but the geology of Shropshire is quite remarkable. In fact, the Great Victorians, where the great surge of knowledge came about, where people were finding out about the natural world and how it worked. Great people like Charles Darwin was actually born in Shrewsbury, which is not 12 miles from where I actually live. The actual birthplace of Charles Darwin, who was a great Victorian sort of expert on nature, and he devised the evolution of life on Earth. There was another chap which doesn't get so much mention, a fellow by the name of Murchison, and he studied rocks mainly in Shropshire, and a lot of the geological periods, which again is something we'll get onto, because as these changes became about in the Earth's mantle and the Earth's crust, with different things, different geological periods, and I think there's, I don't know, about 13 or 14 different known or recognized geological periods going all through. And obviously they gave these different periods names, and there was the Silurian, the Jurassic, the Ordovician, the Carboniferous, and all these strange names. But I don't want to get into too much detail about all these things, because we'll cover them in later videos as we sort of go through to look at the rocks and the minerals that I've got. Because this video is really a sort of an overview of the whole thing and how interesting it be. And my hope is, I mean, as a collector of these things, what I do, I collect them, I interest them, I study them, and then I stick them in a box and put them on my shed, and that's the last anyone ever sees of them, except occasionally when I get them out to have a look. But the one thing that I enjoy more than anything about having all these geological and sort of specimens and things which I've collected is showing them to other people. And through the medium of YouTube and the videos, I'm hoping that I'll be able to show you some of my things that I've got, which gives me great pleasure in just showing other people what I've got and trying to understand what it is. Now, I've already said that I'm not an expert, so what I would emphasize all the way through this, that maybe when I'm chundering on like I do, I may get something wrong. I may not actually tell you either the whole truth, or may get things a little bit muddled up, because I'm not an expert. I don't claim to be an expert. But what I suggest you do is, if any of this interests you and you want to get into it, then by all means study it if you can, but find out for yourself. Go through the internet, go through the various ways, but the best way I find is by books. And it just so happens I've got a book here which I'll just show you, which was given to me by somebody who is an expert, a professor, Dr. Peter Toghill, and he's a professor of geology at Birmingham University, and he gave me this book, and he signed it for me, which is rather nice. And this says, The Geology of Britain, an Introduction. Now, he's written a book, and quite a big book at that, and it's fascinating. I've looked at it, and occasionally, while going through this series that I'm thinking of doing, I may refer to this book to try and get some of the facts right, because I may get them wrong. Now, I mean, don't take everything I say as gospel truth, because I may have got things a little bit mixed up. They aren't far from the truth, but I'm not deliberately trying to mislead anybody. So to find out, to make sure that you get it exactly right, look at a book. Find out from the experts exactly what it is. Now, while I'm on the subject of books, I'll show you this little book, which is a funny little book, and this is on Shropshire geology. And the interesting thing about this it's a little guide, really, that was produced in order to take people around Shropshire and looking at various aspects of this really remarkable area. To have so many of the geological periods in one place is quite remarkable. I mean, you go to foreign countries and they've got perhaps dinosaurs, and you go to another country and they've got some other kind of geological features and different parts of everywhere. But in Shropshire, you can actually study nearly all of the geological periods within a single county. Now, that's quite remarkable. And it's lucky for me, because it meant that I didn't have to travel far to look for rocks and minerals and fossils that date back to millions of years ago, and get an interest of what's going on. So Shropshire is a great place to visit, and if you ever get a chance to come to England, visit Shropshire, because you'll find it really interesting. Now, the interesting thing about this book is, on the very front page, if you look there, you'll see an advert, and it's for the Crystal Man. Now, if you look underneath there, you'll see it's got a name, and it's my name. Now, some years ago, I had a shop, and I actually sold rocks, fossils, and minerals. And that was an advert that was put in this book for my shop. There I am, Jim Kelsall, and that's who I am. And I was known as the Crystal Man. Now, crystals are again a fascinating subject, which I find very interesting, because everything pretty much that's known about the earth and the minerals and even fossils have some connection in some way with crystals. Everything seems to be made of crystals, apart from gases, of course. But when gases actually condense down, they're quite capable. I haven't brought the one in which I was going to show you, but I've actually got a mineral called menthol, which is a gas, and menthol, you probably used menthol in sweets for coughs and colds and things, and menthol is good for your lungs. It clears out guitar and stuff like that out of your lungs. So it's actually a sort of a vapor or a gas. But I've got a jar in the shed, which I'll show on a future video, of menthol vapors in a jar, and they have actually formed crystals within the jar in midair, not sort of connected to anything. They've actually grown like long glass-like threads of crystal from the side of the jar and inside the jar, on the walls of the jar, and they're actually menthol crystals. So even gases are quite possible to have a crystal structure. Now in chemistry, which is another thing I'm interested in, very often when you boil things down and you get a pure salt, as they call it, and you get things down to form and evaporate the water off, crystals will be formed. Now that really shouldn't surprise anybody, or it may not be a surprise to anybody, but I find that fascinating, and I love crystals. I'm always looking out for crystals, and I buy them all the time. Now there's loads of crystals, different shapes, and very often you can identify what a mineral is or whatever it is by its crystal shape, and very often they're pointy things or six-sided hexagons and square blocks. And I've got several of them here, and we'll have a look, start looking at some of the rocks now, because I don't know how long this video can go on for. But here's a mineral which everybody may recognize and be interested in, and straight away you can see by looking at it. Let's turn the light round a little bit more. I don't want to blind everybody with this light, but you need plenty of light with these videos so you can see. But it's made into sort of square blocks, and it's a goldy color, and but it's certainly not gold. I wish it was. If I got a lump of gold this big, it would really be interesting. But they actually call it fool's gold, because if you found this in small pieces in a rock, especially quartz rock where you find gold, you might think that this was gold, but in actual fact it's not gold. It's a mineral called iron pyrite. Now there's iron pyrite, and there's another thing called chalcopyrite, which is a copper pyrite, and it forms similar crystals, although the copper pyrite has usually got all other colors in it, and purples and blues, and it's very pretty. And they call it peacock ore in some places because of those bright colors that it has. But what I wanted to show you with this particular lump is it can be sort of a lumpy coal-like structure, but it can form crystals. Well, as I say, everything forms crystals, even metals. If you magnify a piece of metal up, like I don't know about copper, but certainly brass and different things like that, and you put them under a microscope and magnify it tremendously, you will see that the actual metal is actually made up of tiny crystals all joined together to make a piece of metal. Now I find that fascinating. The crystals grow, and crystals are found in everything. Now the thing about crystals is not only can you find them in nature, you can man-make them. I mean, this piece here, for instance, is a man-made mineral, or whatever you want to call it, but it's got a crystal structure, and if you look on the top of there, it's pretty colors. If I can shine the light so that it shows the colors, I don't know whether it will or not. The light isn't quite in the right direction, but maybe that'll show the colors a bit better. I don't know, moving it about. It looks a bit like a lump of coal, but in actual fact it's a mineral called corundum. Now when they make corundum, which is not a natural I mean, there is a natural corundum, which I'll show you in a minute, but this is a man-made corundum, which is cooked up in a furnace, and they use this for grinding powders and polishing powders, and use it to grind and shave down different things. I mean, it's very hard. It's a bit like almost the next hardest thing to diamonds, and so they use this in the process of polishing and cutting and doing stuff like that. But it has a skin on it, and when it has a skin on it, when it's been made, it actually forms crystals, and you can just about make out on the edge of this specimen where there's crystals forming on the edge here. So even this material that is man-made will actually form and make crystals. Now let's have a look. Another mineral which I'll show you, just to show you another one that you'll probably recognize, is this one. Now again, I don't know whether the light is terribly good, I'm trying, but this one is green and it's got bands all through it, and it actually forms crystals as well, although this is a large lump that's been carved into a sort of a dish or something. I broke it up because I didn't want the dish. I think it was broken when I got it. But this is a green mineral, and this is called malachite. Now malachite is a very useful mineral. In fact, it's one of the ones on the periodic table. It's a bit like the galena. It's a metal ore of copper. And what they do, they crush this galena malachite down and put it into a furnace with charcoal and maybe other bits of flux and things, limestone, which is a sedimentary rock, which I'll show you some limestone in a minute, which has fossils in, and they cook it up in a big furnace and they produce copper. So that's where you get your copper from, as a metal. But copper in its natural state is this green material, malachite. Now, I was talking earlier about volcanoes. Now, when a volcano spurts up and magma and stuff comes out of it, you sometimes get an area where the actual magma doesn't come out of the ground. It stays underground and forms granites and various minerals. But one of the things that it sometimes forms is a glass-like material. And this one here is quite an interesting little lump I brought in just to show you. This is, for all the world, like a piece of glass. It's like a glassy type material, and if you notice within it, it's called Snowflake Obsidian, and the reason it's got those white flaky bits is because as this cooled down, it cooled down quite slowly, and as it was slowly cooling, crystals started to form within the rock before it set hard, and those white blobs are actual crystals trying to form within the liquid glass as it cooled down. Now if it cools down quite quickly, then the crystals don't get very big, and therefore you see them as these little white lumps. If it cools down even quicker than that, no crystals form at all. It just forms a solid black glass-like material, which they call obsidian. But this one is Snowflake Obsidian because it cooled a little bit slower and started to form crystals. This one's got a bit of brown on it. It comes in different colors. It can be jet black or it can be brown. So that's an interesting rock to collect. Now, I was talking before about minerals and having strange properties. Now I've got a couple of boxes here which are actually teaching specimens for schools. Now inside this box here there's a load of specimens. Now maybe you'll be lucky enough to go to a sale somewhere where you'll see rock specimens in boxes like this, and this one has actually got two boxes. I'll show you the other one just briefly. These are what we used to put together. A friend of mine who used to do geology when I had my shop, and he actually is the author of that book I showed you earlier on, a chap by the name of Robin Stratford, and he had a company called Offer Rocks locally, and he sort of introduced me even more to rocks and minerals, and that's how I came to be the Crystal Man, was as a result of my association with Robin. And in here there are specimens of all different types of rocks, and each one has got what we call a spot number. In fact, on that one there's number 34. Now those numbers are quite significant. I mean, this happens to be a piece of ironstone. Now those numbers are quite significant because when you compare the number on the rock with this list which comes with it, it'll tell you exactly all about that particular rock. And you've got a little bit of information there. Now this is used in schools for teaching purposes, and you see there's quartz, different kinds of quartz. There's jasper, chalcedony, flint, chert, and all sorts of minerals, and it goes right up. But the reason I brought this box in to show you really was because one particular mineral the way I want to show you in here is this one, and it's number 40 on the chart here, and it's magnetite, and it has an interesting property. Now, most minerals, I've got on here a little magnet in this little fridge magnet. Now, when you touch the fridge magnet on most of these minerals, nothing happens, even though they're iron. I mean, this is ironstone here, and I touch a magnet to it, nothing happens. But when you've got magnetite and you touch it on a magnet, it sticks. So rocks can be magnetic. They can actually be attracted by a magnet. And although I couldn't find some when I was going to make this video, I'm sure I've got some in the shed, and on a later video I may show you. We can actually get magnetite, which is itself is magnetic, and it will actually stick to a piece of metal in the same way that this magnet is sticking to the magnetite. And that's interesting because this was known about probably hundreds and hundreds of years ago. In fact, they maintained that the Vikings used to use compasses made with magnetite floating on oil or water, I don't know, as a navigational aid. Now, as we go on, you'll see how all these sort of different minerals, well, I've already said how useful copper is in electronics and for electricity, and even making electricity. So magnets, another useful thing, which nature had already invented long before man ever decided to use it. Nature was building all these strange and mysterious things in its own chemistry laboratory, which is the earth itself. Now, another interesting property of minerals, and I've got one here, and if I just turn out this light, so we haven't got quite so much light in this room, I'll just turn off this other light for a second, so it's a little bit darker in here. If I turn the camera a little bit towards the darkness, I've got another mineral here, this little tiny one. It's a bit small, but it's actually another mineral, and it's called fluorite. Now, we'll cover fluorite in another video about different types of fluorite, but this particular piece of fluorite is interesting. It's got a strange property, a bit like that magnetite was magnetic. This particular rock has a strange ultraviolet light fluorescence. Now, here I've got an ultraviolet light, or black light some people call them, and if I turn it on, you'll see it glows sort of, it looks blue to me. It might not look blue to you, it might look a different colour, but when I shine it, this ultraviolet light, onto the fluorite, it fluoresces. If I turn it away, you'll see how it changes colour. Bring it back. Now, if I do that on, say, this piece of malachite, it doesn't do anything, because malachite doesn't fluoresce. Now, you may say, oh, that's interesting, that you've got a rock that glows in the dark almost. It's not radioactive, but it fluoresces under ultraviolet light. Incidentally, paper fluoresces as well. You can get paper to fluoresce. But it's interesting to note that you've got minerals which have fluorescent properties, and that just happens to be one of them. I've got some which are actually radioactive, which they find in granites down in Dartmoor area, and it was a cause of some concern at one time that people were getting slight radioactive sort of radon, I think they call it radon gas, was coming out of granites which were down in Cornwall area, down in Bodmin Moor and places like that, where they have these huge granite areas, and they were getting these gases out which form yellow crystals on the rocks. When they solidify, they turn into crystals, back to crystals again. They turn into crystals, and they are actually radioactive, and there's quite a lot of minerals which are radioactive. I haven't got a lot of them, but I have got some, and I've collected them myself. Now, the other thing we were mentioning was fossils. Oh, just before we go on to the fossils, remember I was talking about the thunder egg? Well, I've got a big thunder egg here, and as I said, These are what we call geodes nowadays. The thunder egg, which I think they were talking about on the Wonder Horse story, were a slightly different beast to this. But these come from Brazil, and what they are is huge gas bubbles. It's got a green texture on here. So these were gas bubbles inside granite rocks, I believe, and the crystals formed inside these empty cavities, which filled with silica liquids, and crystals grew. As they do, if a mineral gets a chance, it'll form a crystal, and inside, I don't know how clean this is, it's a bit dusty, but you can see this is a huge geode full of crystals, and this one happens to be amethyst crystals. They're purple, and again they're purple because they've got mixtures of iron inside there. And if this was to heat up, if I was to put it in an oven, cook it up a bit, these crystals, the iron in these crystals would turn brown, and you'd get another mineral which is well known, which is called citrine. Citrine is also sometimes called burnt amethyst, because if you heat it up, it turns brown, and you get the brown colour of the citrine crystal from heating up amethyst. Now that's quite heavy. Now, the other thing I wanted to talk about, just to wrap up this particular bit of video, was fossils. Now, when you're digging about in rocks, sooner or later you're going to come across fossils, and there's a lot of them in Shropshire. Some very interesting ones. I haven't actually, apart from this one, which I told you about, limestone. Now, this is a piece of very famous limestone, at least from a geological point of view, because all over the world, when geologists look at limestones, they classify them as Wenlock limestones. Now, Wenlock Edge, where this came from, was a coral reef millions of years ago. It was under the sea, and now it's obviously 70 miles from the sea up on dry land, and it's formed a huge coral reef. And in it, embedded it, I don't know whether you can, how well you can see them, but there's loads of fossils on both sides of this Wenlock limestone. All these different fossils here. There's crenoids, there's trilobites, there's all sorts of different stems and creatures and shells, all trapped within this, what is limestone. Now, what they would do was get the limestone, cook it up in a big furnace and burn it with coal, and the resulting lime would come out of it, and they could spread that lime on the fields. That's what they use the limestone for. It's used in concrete, it's used in all sorts of processes. So again, it's a thing where you've got a sedimentary rock, which is limestone, and then by a process of science and chemistry, you can turn it into a useful mineral like limestone. Now, we're actually talking about fossils. Now, I've got some fossils here which come from different parts of the world, not necessarily from Shropshire, but one that does occur in Shropshire, but not. This isn't one. I brought it in because it's quite big and I can take it and put it on camera. Now, this one is a fossil known as a trilobite, and it looks like a bit like a woodlouse. They're sort of pretty well extinct now. There's no creature on the earth anymore that's like this. I believe they have found creatures that are very similar to this in very deep ocean trenches out in the middle of the sea, where they found strange creatures live down there. They found crenoids, for instance, that are on that piece of limestone at very deep depths in the sea, and there are creatures that resemble trilobites. Now, when trilobites were on the earth many millions of years ago, there was probably hundreds of different types of trilobite, and I've got several of examples that I found in Shropshire, which we can look at as we go on. But this is a particularly big one, and this one actually comes from Morocco. They find them over there and they sell them, and so it's quite easy to get a Moroccan trilobite. They're not too expensive, but they're interesting. Now, the reason they call them trilobites is because tri is a tricycle, has 3 wheels. These particular creatures have 3 body sections. Now, a lot of people think that when they refer to the trilobite, they're referring to the tail, the head, and the body as being the tri. But that isn't strictly true. That what they're related to is the 3 sections of body going in this direction, which is the 2 outer pieces and the middle. In other words, trilobite. In other words, trilobes, 3 lobes, making up the body of a trilobite. Because when these creatures, this had an exoskeleton. There was no skeleton inside them, but their bones were on the outside. They had an exoskeleton, and the exoskeleton is here. Now, when these creatures died, the tail would fall off, the head would fall off separate, but the body would be lots of little segments, so they'd be scattered all over the place. And very often when you're looking for fossils of trilobites, you find only the tails, the heads, and the body section scattered everywhere. When you find them in one piece like this, it's because somehow they got covered up and died, and they were kept together, and they formed into the rock. Now, another fossil that's quite popular is a thing called an ammonite. Now, here's an ammonite. I'm trying to get the light on it so you can see it really well. And it's black, but it's a genuine fossil. It doesn't look like it. It may look as if it's been made. And in fact, you can make molds of fossils. And I've got no objection to that. People make molds of fossils. I've done it myself. Because very often a very rare fossil can't be replicated by finding it as a genuine thing. So you make a mold of it, and then you can produce lots of them, especially for teaching purposes in schools. If you want to teach people about fossils, you want to make sure that all the pupils get the same information, so you need the same fossil, and if there's only one of it, then you can't spread that around a whole class. But if you make models of it, then you can give each child one, and he knows exactly what it's looking like, and he can be taught about it. Now, this is a genuine fossil, although it may not look it, but it is a genuine fossil, and I've made molds of this so that I can sell them to schools and give them away as people to teach what ammonites are like. Now, this is the outer case of the ammonite, because it's like a shell. It's a bit like a nautilus. There was ammonites and there was goniatites, which are more related to the nautilus, which is still alive today, but there's no ammonites as such, as far as I know. This is another ammonite, and the reason I brought this one in just to show you is because you can see how pretty it is. Fascinating. Now, this has been ground down so you can see the inner structure of this curly shell. And every year of its life, it would grow one extra shell piece on here. And these are what we call the suture lines. It's where the 1 year's growth of shell joins onto the next year's growth of shell. And you see that by either cutting it in half or polishing the surface off so you can see the inner structure. And I just thought I'd bring that in just to show you the inner structure of a trilobite, of a ammonite, sorry. Now, obviously, there's another one here, which I'll just show you quickly, is this one. Now, this is another fossil, and this is a shell of another fossil. I think it's the shell. I'm not quite sure whether I've got it right now, but this has got the same sort of situation where it's got different chambers all the way along. And for the life of me, can't think of the name of it offhand. But that's another creature. Oh yes, I've just remembered. It's called an orthoceras. It's an orthoceras. And it was a shell-like creature which lived in the sea, and this has been polished so you can see all the inner chambers of it. So that's the orthoceras. Now, of course, one of the things that survive when you're a fossil is your bones and your teeth. Now, I've got a fossil here, which is quite interesting. If I can bring it in and show you, this is a huge tooth, and again, it's a genuine fossil. I wasn't too sure when I bought it whether it was genuine, so I actually dug out around it to make sure that it wasn't a casting. And when I dug through, I found other bits of shell and bone embedded in this piece of rock. So it tells me that that is a genuine fossil. And I think this is a mosasaur tooth of a creature that, a bit like a crocodile, that lived many millions of years ago. Well, I don't know about millions of years, perhaps hundreds of thousands of years. Related to the crocodiles, and it was called a mosasaur. So that's a tooth of a mosasaur. A lot of things you find in well-known fossils are shark's teeth, which survive, and I've got loads of those, and I'll show you them as we go on. Now, the other thing you find, and this was probably come from China, are fossilized fish. Now, that fish is in a sandstone, which is a sedimentary rock, laid down in a shallow sea probably, and this fish died and somehow got covered in sand, and there he is. All his bones have been picked out and he's fossilized, and you can see him, every detail of him. You can see the fins, you can see the bones, and you can see the jaw and the tail, just like a fish. Now that's interesting because you can study the creatures that lived millions of years ago just by looking at their bone structure. Now I think we've probably come to the end as far as this particular session goes. I've got some other things here which I sort of skipped over, which I thought I might show you, but I'll just pick one out. This is an agate. Now you saw the geode there which I showed you earlier. Now if that geode was left in the ground where it was and it continued to fill up with crystal, eventually that solid, that open cavity would actually fill up and completely full, and then it would become fully agatized. Now this is an agate, and if you look you can see how this particular agate has grown up layer by layer by layer by layer into a solid rock of quartz, which is now formed, and they call that agate. And this is, I think they refer to this as Botswana agate. I don't know why they call it Botswana agate, but it's known as Botswana agate. But you can find these sort of things up in Scotland and England, so they're all over the world where you can find quartz crystals and rocks which have got agatized materials in them. Now the other thing I wanted to mention was, of course, when you've got crystals being formed, you get crystals in their very pure form, and they can be cut into various gemstones, and all the jewelry that you see around comes from the earth as well. And there's various gemstones, garnets, diamonds, rubies. Now while we're on the subject of ruby, look at this one. Now this is a crystal, sort of a layered up crystal. It's bright red. Now that actually is a ruby. Now if it was a gem quality ruby, it would be worth an awful lot of money, but it's not. It's got a lot of imperfections. Somebody has tried to cut it to make it into sort of jewels of some sort, but it's not a pure crystal in order to make a gemstone out of it. But it's an interesting specimen, and in actual fact it's carborundum. Now when it's blue they call it sapphire. When it's red like this they call it ruby. Now it's very similar in properties to this carborundum here, which is man-made. This one is a natural corundum, which is ruby. And there's lots of different ones. And as we go on with the series, I'm hoping to show you my collection, of which I've got many hundreds of different specimens of minerals and fossils and rocks, which I find very interesting, and I hope you do too. So I'm hoping perhaps young people who hopefully maybe get to look at this video and think, well, if he's interested in minerals, maybe I ought to take a look at them and find out a little bit about them, and maybe they'll start a whole lifetime of collecting rocks and minerals. And who knows, they may actually take it as a subject in their teaching and learn all about it and become a professor like Peter Toghill, and you know, study geology. I mean, geology is really wonderful thing to pursue if you've got the brain power to be able to do it. I mean, the oil industry love geologists. You get a really high paid job if you're a geologist in the oil industry, because they're constantly trying to find where minerals and rocks are formed. I mean, and people have been doing it for millions of years. I mean, when I was talking about the lead mines in Shropshire here, the first people that dug up and used the lead in those lead mines were actually the Romans. 2,000 years ago, the Romans came to England, and what they were after was not the people, because they weren't worth anything. What they were after was the minerals. The minerals that are buried within the earth of England were quite valuable, and they mined lead in Snail Beach area, and there's actually a mine called the Roman Levels, where the Romans actually dug for lead. So it's been going on for an awful long time. I find it incredible to think that people in primitive times, especially the Bronze Age and the Copper Age, when somehow, and this has always been a mystery to me, how people found out that by getting these green rocks out of the ground and cooking them up somehow. I mean, how they would know how to do it is absolutely mind-blowing. I mean, it's very difficult. I mean, it's not an easy process even in modern times to do the chemistry necessary, or to produce the heat necessary to cook up a piece of stone like that and turn it into a bright, shiny metal. Now, the people that managed to do that in primitive times, well, it's mind-blowing. I just can't imagine how they found out about it and how they discovered it. I mean, it isn't something you discover by accident. You'd have to be looking for it to discover it. And how they knew to look into rocks and discover that there were things buried within rocks that could be useful, I don't know. I mean, if they hadn't, we'd still be living in the Stone Age and we'd still be bashing people over the head with clubs. But we managed to do it somehow, and knowledge gradually grew. And it's only by studying rocks and looking at minerals and doing chemistry and science that the world has evolved into this most wonderful place we live on. And we ought to every day be grateful that we're given this pleasure of having such a wonderful world in which to inhabit. Well, that's enough for me. So I think I'll cut off now. And I hope I've given you some insight into something that interests me greatly, and I hope may find of interest to you. So bye now. I'll see you again. Bye bye.